Okay, well, thank you very much for waiting for this next session. I am really looking forward to hearing Miriam talk about. Miriam, welcome. How are you? We can't hear you at the moment.
Hello.
Hi, welcome.
Hi, can you hear me now?
Yes.
Thank you very much. Thank you.
We're all really looking forward to hearing you talk about DEWA 950. I was lucky enough to, to also attend your chat the other day, but a lot of the people here probably haven't. So this is the second session for today, guys. We're going to go in depth into DEWA 950, which at the moment is the biggest milestone for CSP. So Miriam, I'd like you actually, Manuel, if you can stop sharing the screen so Miriam can share hers. And let me just give you a little bit of a reminder. That's just to make sure that you guys send your questions through the Q&A. Just to make sure that we are recording the sessions, we will send you the link and we will send you the material, so you don't have to worry about that. My colleague Manuel has been sending you messages with the interpretation link. If you need interpretation to Arabic or French, it's available. And I think those are all the messages. Do you remember how to share the screen, Miriam?
I should.
You open the document first.
It was supposed to be on the top, no? No, it's below. Okay, fine.
Yeah, below. Share. Once you open the document, then you press share, and then you just open the document.
Can you see it?
Yes, I can. Can you make that large for me now? Because we can still see the PowerPoint. Yeah, right there.
Okay.
Okay, we're ready for you.
Perfect. So good afternoon or good morning, depending on what's your location. Thank you very much for joining us today. My name is Mariam Belizim. I am a Senior Business Development Manager in Aqua Power. So I work mostly on the MENA region and focusing more on renewable projects. So I have attended yesterday actually the seminar, and I have seen that the project was mentioned several times during the day. So I was happy to see this project, I mean, represented and mentioned by several people that have attended. And so it was mostly on the financing, I think. There was also Paddy who has discussed, I mean, he has explained some things on the project. So today I will just try to give you a global overview of the project and maybe things that you have not been exposed to all of you. So before maybe starting, I would like I have attended also now Michael's presentation, and I have to say that he said everything there on how is the cost competitiveness ongoing now. So just to show you how we moved on from Aqua Power side only when it comes to PV and CSP, because the project DEWA is a project, DEWA 4 is a project of PV plus CSP, so it's a hybrid project. Then you can see here in this slide how we moved from our first project IPP in PV, which was in 2015, till today, which is in the same location. So from PV DEWA phase 2 to PV DEWA phase 5, we have seen a reduction in tariffs of more than 70%. Within the same location, so it means that we have the same meteorological data with very similar conditions in terms of risk allocation. With so you can see in 5 years how the tariffs have been have moved. In terms of CSP, we have moved from our first project, which has been awarded to us in South Africa, which is Bokport, till today, which which is the DEWA CSP and PV project. We have moved by around 65% reduction in LCOE. So that is very significant in just 5 years. Then we can say that right now we are developing projects that are also participating and pushing for the energy transition toward global energy with zero carbon emission. This is the purpose of Aqua Power also in all our renewable projects. So when it comes to DEWA CSP PV hybrid project, it is not just a 700 megawatt CSP project. It is, as I said, owned by one company which has been incorporated in Dubai, named Noor Energy One. This company is having several shareholders, 3 shareholders. So we have DEWA as off-taker and also as a shareholder. We have Aqua Power as a shareholder, and we have also Silk Road Fund as another shareholder. So the 3 of them have formed this company, which is currently implementing and doing the construction of and owning the project under construction. So when we talk about 700 megawatt CSP and 200 PV, you can see the 700 is the largest concentrated solar power plant in the world. In one project, we have seen several projects, for instance, before as different units owned by each by a project company. Here, it is not the case. There is one owner, which is one project company, which is Noor Energy One. So it has reached several records, this project, since 2017, since its award till today. And we can list some of them, like the lowest LCOE of 7.3 cents US dollar per kilowatt hour. This level of LCOE, we have seen that in 2017, it was a very important project because of the low tariff that it is providing, which is competitive with fossil fuel. And being in a region that is very much depending on fossil fuel and which has a very an increase in energy consumption, it's very important to have this kind of project. So the project is generating 24 hours. It has enough thermal storage in order to generate during peak time whenever it is required. And here in Dubai, for instance, in our location here, we need energy mostly during the night because there is peak time. During the day, we can use PV, there is no problem, but during the night, we need some energy. And having this energy coming from solar, it's made this project very special. So the 700 megawatt is a mix of central tower and also parabolic trough. So for the central tower, it is just 100 megawatt, and it has also the highest tower in the world of 260 meters. When we hear 950 megawatt, it's very different to say that it's 950 megawatt of PV or 950 megawatt of CSP or a mix of them. So having 700 megawatt of CSP and 250 megawatt of PV made this project to be the largest investment in the world in terms of in renewable. So with an investment of 4.3 billion US dollars, sorry. What made this project special? So just to give you of background, we have started with a tender to be submitted in 2017. It was a tender issued by DEWA, which is the government of Dubai here as off-taker. The tender was 2 towers, each of 100 megawatts, so a total of 200 megawatt project, 2 towers. And that was mandatory as base proposal. Then the bidders had the choice and the flexibility to provide another proposal, which is an alternative proposal, but showing value, of course, if we want to move from the base proposal to the alternative proposal. So within Aqua Power, we have worked on several combinations, and we found out that this combination of a mix of technologies was the best for us. And so the project has been awarded to us based on this alternative proposal, thanks to the value proposition that has been delivered to our client. And just to list what are the key values here is first the LCOE, which is of 7.3 cents US dollar per kilowatt hour. It was the lowest LCOE in the world. The flexibility of dispatch in 24 hours. So not only having energy available during the night from the CSP, but also to cover all the intermittencies during the day whenever it is required, or even during peak time. The integration of the three technologies smartly has also played a big role in terms of how to optimize the project and make it more competitive. And the final point is related to the highly strategic project. So we are talking here about two countries between China and Dubai, and the UAE, the government of Dubai, had a very strategic relationship also in terms of participation of both, for instance, the Chinese shareholders. Silk Road found in the project to be one of the shareholders here. And of course, all this, this project is part of the Dubai Clean Strategy in having and generating 25% of its energy from clean energy, from renewables by 2030. So that was a big portion that was covered by this project already. Okay, so here are some details on the project. As we said, it was an IPP project, so a standalone greenfield IPP. Off-taker was Dubai Electricity and Water Authority. It is an off-taker, but also a shareholder with 51% shares within Noor Energy One. And in addition to DEWA, as a shareholder, we had Aqua Power with 24.99% and Silk Road Fund, the Chinese shareholder, with 24.01%. The project was located within the same solar park. So I will show you later, it will come in the next slide, the solar park to have an idea, which is the Al Maktoum, Mohammed bin Rashid Al Maktoum Solar Park within Dubai, based on a develop, build, own and operate structure. The capacity, as explained before, is 950 megawatt with 3 units of 200 megawatt parabolic trough and 100 megawatt central tower. The thermal energy storage TES was of 15 hours in total, and in addition to that we have the 250 megawatt photovoltaic PV. The EPC contractor that we have selected has been a challenging point that we will go later on for the challenges, because the project was a total of 4.3 US billion. So it was important to find an EPC which is financially and technically capable of wrapping the project. So we have ended up selecting Shanghai Electric Group company as EPC contractor. So just for your information, the EPC contractor had to be capable of providing all the bonds and the guarantees for the project in case of any issue with the project, and needed to have a very solid financials. So Shanghai Electric is also listed in the stock market of Shanghai and Hong Kong, and is also rated A2 by Moody's and A by S&P and Fisher. So you cannot find, we couldn't find many EPCs in the market who were able to wrap up a project like that. The O&M contractor is NOMAC. So NOMAC is a company that is owned by Aqua Power that operates most of our portfolio, and included in this portfolio we have Bokport project in South Africa, Noor 1, Noor 2 and Noor 3. So it has a good experience in operation of CSP, either tower or parabolic trough. Then it has been selected to work as the O&M contractor for this project. Under the EPC contractor, we have we have selected the technology providers. As you know, for CSP, it's not like in PV, where you can just purchase the panel and the equipment and then start the construction with an EPC contractor. Here, no, it's not the same case. We needed to have technology providers who could be responsible, who could first own the technology and who could be also responsible for all the scope under the equipment under their responsibility. So for the central tower unit, we have used Bright Source technology. And for the parabolic trough unit, we have used Abengoa's technology. And both of them have entered into JVs with Shanghai Electric to form the key subcontractors for the project. Out of the total investment cost of the project, which is $4.3 billion US, there is in this project a huge amount, a very significant amount of senior debt, which is of $2.4 billion US. And when we say this number, then you can imagine the challenge that we had in closing the project by having several banks. So we had local banks, we had international banks, and then we had the biggest portion that came from the Chinese banks for this project, totaling the 2.4 billion. Another particularity of this project, as just was mentioned by Michael before, is that the PPA is of 35 years. We usually see PPAs of 20 or 25 years, but here we have seen, we have managed to extend the PPA till 35 years. It was a first for CSP project. And then the PPA at the end was signed by, as we said, the off-taker, which is DEWA, and then the owner, which is Nor Energy 1. So here I think you could see better in a scheme who are the key shareholders and the key stakeholders of the project. So we have on the project company in the center, which is Nor Energy 1, owned by DEWA and Aqua Power Holdco. DEWA 51%, Aqua Power Holdco 49%, and then within Aqua Power Holdco, we have Aqua Power and Silk Road Fund, each of them with Aqua Power 51% and 49% for Silk Road Fund within the Aqua Holdco. From the lenders side, all the lenders had the financing agreement, so they entered into a CTA, and it was closed by last year. There was a PPA, as we said, signed with DEWA, so you can see that DEWA is present here as a shareholder and also as an off-taker separately. There was an EPC contract also executed, so it's a lump sum EPC contract based on one price contract, which was signed with Shanghai Electric, and then under Shanghai Electric, there was the key subcontractors of the technology provider Bright Source and Abengoa as technology provider for the parabolic trough. Here we can again say that Shanghai Electric is wrapping all what is under the EPC contractor, which gave a lot of comfort to the lenders. And then there was an O&M contract. In addition to that, we needed to have an owner's engineer, and we have appointed Worley Person as the owner engineer to review the document of the project and also the construction of the project, supporting the project company. So here you can see how the solar park is and where the project is located exactly in the solar park, and how the previous phases and the future phases are going to be located. Mohammed bin Rashid Solar Park has started with the first project, which was not an IPP, it was an EPC project of 13 megawatt, which is the small rectangle here. And then after that, there was the phase 2, which was the first IPP here in Dubai, to Aqua Power, which has been awarded to us in 2015. So 200 megawatt here, and then followed by that by phase 3, which is 800 megawatt. And then it came the phase 4 of a CSP PV hybrid project, which is 44 square kilometers. So you can just have an idea on the size of the whole project here. We have the 3 units. So we have the 1 unit tower on that side, and then we have the 3 very similar units to split in the rest of the area of the project. The PV here is located within the project split between different units. For the future expansions, we have the 900 megawatt, which is currently under financial close. It has been awarded to Aqua Power recently. And then after that, we have future projects which have not been yet tendered by DEWA. So some key points on the project also. So we have, I mean, having a project here in Dubai is different, and we have to say that we have been quite lucky in having it well located, which is not far from Dubai at all, 70 kilometers from Dubai and 90 kilometers from the port of Jebel Ali, with very easy access through motorways. So we did not have to improve the road or search for a way to transport the key equipment, especially the largest equipment, like we did, for instance, in other projects in either in Bokport or in Morocco. So that was a big advantage to us. The technology for the central receiver, so we are using the central tower, obviously, heliostat, and in addition to that, we have used molten salt. And for the parabolic trough, we are using thermal oil, in our case HTF, plus molten salt storage. And then for the solar PV, there is no storage in it. Maximum export capacity is of 950 megawatt net. So 100 from the central tower, 600 in total for the parabolic trough, and 250 net in the PV. For the solar field, the technologies that we have been using are the heliostats from Bright Source, as explained before. So we use the LH 2.5 technology from Bright Source, which was very suitable to the site, because we have to take consideration that the site has big dunes. So that specific heliostat was the best technology to choose in terms of optimizations. And also, this heliostat does not require cabling connections, so it was very easy for us. Even if it's a very large solar field, it was very helpful to not have to connect the heliostat by cables. From the parabolic trough units, the 3 units, so we have been using Abengoa's technology, and we use the latest collector of ST 8.2. When it comes to PV, so we had 250 megawatts of megawatt AC to dispatch to the grid, but we also had, I mean, now is very much used even in water project, etc. We had also internal consumption for using PV. Of course, the internal consumption facilities were not able to dispatch to the grid, then it's completely separated from the 250 megawatt. The central tower molten salt receiver is a technology provided by CMI. The thermal storage in the central tower was of 15 hours, and then in each of the parabolic trough was 12.5 hours. The cooling system, as we are in a location where there is no water, so we used an air-cooled condenser, And for the electrical connection, so we are connected to a 400 kV substation, which is owned by DEWA. But within the project itself and within each unit, we had some substations, and we had also switching stations, given the distance, the large distance between, for instance, the units which are far from the corner or close to the corner of the interconnection. From the advisor's side, given the project is complex, having 3 technologies was not an easy project in terms of selecting the advisors, giving comfort to either well within Aqua Power or to the lenders or also to the off-takers. So there were different advisors which has been selected specially for this project. So we as Aqua Power had our advisors and as sponsor for technical, legal, tax, and insurance. And then the lenders also had their own advisors, which also covered the technical side, the legal, tax, and insurance. And in addition to that, DEWA had its own advisors, including finance advisor, technical advisor, and other advisors also. So the work of each stakeholder in the project and their advisors have been coordinated in order to reach the best risk allocation for the project and justify every bit of it. For the solar resource assessment, it was very important to have the satellite measured data, and also the data which was measured on site. So as you know, we have our projects there since 2014, 2015. So we were lucky to have some data already available at that time. And we worked on it either for the DNI or the GSI. We have used also some other satellite data to help us in finding, in building the project based on proper data. So the operational life of the project is of 35 years from initial acceptance of the plant. So we have different units. Each unit has its own initial acceptance, but then we have a plant initial acceptance, which is once all the units have been achieved. So counting from there, there is 35 years of PPA, which are under, of course, guarantees from the owner, in this case, Noor Energy One, to DEWA as off-taker. Savings that have been generated in this project are 1.6 million tons per year of carbon emissions, and we will be able to power more than 320,000 residential units in Dubai. So from the contractual timeline under the PPA, you can see here, as I said, so we had the NTP, which has been issued by end of 2018, December 2018. And then we reached financial close by March 2019, so last year. And then for each unit, as we said, so there is the parabolic trough unit 1, and then there is the central tower, and then there is the parabolic trough 2, and then parabolic trough 3. Each of them would have a date to so there is an initial acceptance date, an ICUD date, and from this in about phase 3 is the one who is going to be reached, then the plant COD date would start from that date. Then you can see here that phase 3 PT ICUD is 22nd of December 22, and then the plant COD date is the same date. And after that, there are 3 years of guarantees from the EPC contractor, as usually. So a quick overview on the key dates here. So the tendering, as we said, issued in 2017. After that, there was the bid opening in June 2017. And then the project has been awarded to us. So we signed the PPA just before the ceremony of inauguration, of groundbreaking by March 2018. Following the signature of the EPC contract was done in China also in April 2018. Then after the EPC contract has been signed, the leaders have met. So the head of state of UAE and China have met in order to discuss the project. As I said before, it's a very strategic project for both countries. After that, there was also a visit to Spain, and given that the project has 3 parabolic trough units coming from a technology that is provided by Abengoa, which is a Spanish company, then also the project has been highlighted and discussed by the head of state of China and Spain. And following that, there was the issuance of the NTP. From the NTP till the last the initial acceptance of the plant, which is the last unit initial acceptance, there are, as I said before, 3 years of guarantees by the EPC contractor. Okay, so the key challenges that have been faced in this project, we have split it in 2 phases. So there is the challenges that have been faced during the development phase of the project, and then there is also the one that has been faced during the construction of the project. So during the development of the project, the first point was the technology risk and the selection. So how did we select, how did we come to this 950 megawatt? How did we select one tower only and then 3 parabolic trough units? So it has been done based on first meteorological data. So we have been working long time on how we optimize this, how we optimize the configuration of the plant based on the data that we have here available on site. So the solar resource, and very importantly, atmospheric attenuation for the central tower, and also the wind. So that was very important in defining the 100 megawatt central unit, and then also the addition of 3 parabolic trough units plus the PV unit. In addition to that, from the technical components, we have worked long time also. We have done so many simulations to reach what is the capacity that can have each unit, for example. What is the optimal number of hours for the thermal storage? What would be the solar field size? And also the tower height. So here the combination of all this optimization has led us to reach the project as it is today. The second point was EPC risk and the expertise. So as I said before, having a $4.3 billion project is not easy to find an EPC who is quite capable to execute it and to wrap it and take all the responsibilities as an EPC contractor toward even his subcontractors. So we have ended up selecting Shanghai Electric, which was a very robust EPC, as I said before, recognized globally and financially and technically very robust. So we have selected them, and then based on this, when it comes to the technical expertise only related to CSP, they have selected also, together with the support from Aqua Power, the technology providers who were also very much experienced. So we had, I think yesterday, Yajesh has explained a little bit what was the experience of BrightSource. So you could see that BrightSource is having for now the largest project under operation of tower. So we selected price source based on that, in addition to the technology that they have in the heliostat that brought a lot of value to the project because of the location of the project and because of the conditions on site of the project. And in addition to that, we have selected Abengoa together with Shanghai Electric to provide the parabolic trough technology. And we know that Abengoa has so many projects and so many experience in terms of parabolic trough that we counted on them to provide this technology. But the most important thing here is that all the EPC risk is taken by only one company, only one responsible, which is the EPC contractor, and in this case is Shanghai Electric. In addition to the technology providers, we have also requested the EPC to use an engineering firm that is experienced in CSP, and in this case we have used Empresarios Agrupados in the project. So they are supporting the EPC contractor in terms of engineering and coordination for CSP technologies. And other than the parties who are involved as subcontractors or as key subcontractors, are the components of the project, which are the equipment that have been selected or that has to be selected for the project. So we have imposed certain track record and a certain experience for especially the main equipment that the EPC has to take in consideration to make sure that the project is going to be executed based on equipment which have been approved and proven their experience and satisfaction to us. The last point for the development phase, it was availability of liquidity and lenders' comfort and sign off. And I think that was detailed very well yesterday. So again, because of the project large amount, we needed to have a lot of liquidity available, which took us a long time to find, but we have found it, and that's what's made the project using, for instance, a large number of lenders. And then we moved to giving conformed to the lenders by, of course, doing some due diligences and using the best consultant to support the lenders in this. So for the key challenges after financial close, which is mostly during the construction phase, during the year of 2019 mostly. So the first point was related to the adaptation to the site. So we are here in a location that is quite different maybe from where our EPC contractor is used to work. So we have certain weather conditions here, like summer, which is very hot, very humid. We have also some local requirements, like when we talk about the required approvals or permits, for instance, having Ramadan period here, how to deal with it. So there are some conditions which the EPC contractor in our case was not very much used to it. So it took some time to get adapted to the site and also to the location generally. The second point was related to coordination. So given that the project has first 3 technologies, which is not something easy, meaning that if we have 3 technologies, we have several subcontractors, we have several key subcontractors, in our case, technology providers. There are many suppliers that enter in the game, and then there is a lot of coordination challenges to be that we found. So in terms of coordination, we had to find out who is doing their first project with so we had to work, all of us and the subcontractors that we had in this project, in order to sort it out. But that was mainly on the first months of construction. But once every member has got used to it, then it was easier to carry on working. In addition to that, having engineering done in several locations, for instance. So there is an EPC contractor who is doing the engineering in China. There is a portion here in Dubai, and then there is also a portion in Spain. It was difficult to do the coordination between all of these and then find the way to coordinate between all of them. So that again took some time at the beginning in the first month until every party has got used to it. So that was also a part of a learning curve, even for execution here. There were the use of some subcontractors who did not have much experience either in the technology or in the amount of work that had to be done, because we are talking, for instance, of 44 square kilometers. Then finding a subcontractor doing the works, for instance, of the earthwork, just as a simple example, it was a bit challenging to find someone who has experience within doing such a big job for a large project. Another point which is related to the equipment. So having 1 unit of 100 megawatt central tower and 3 units of parabolic trough, mainly using very similar equipment, the 3 units of parabolic trough, it was a bit challenging also to get all the POs issued and order the equipment, especially when it comes to the main equipment. So we are not talking about just few equipment, we are talking about 4 units of CSP. So there are a lot of many equipment that have to be issued as POs, and with the timeline that we have, we could not really afford to have some delays in this. So at the beginning it was a bit challenging, but right now it is under control, which is which we are happy about. And the latest challenge, which I think the whole world is suffering off, is the global pandemic that we are having now. It is still not known. I mean, for now, we don't know what is the impact exactly, but it is definitely a challenge, and it's starting for, I mean, all the projects in the world are going to see this challenge coming. So for the key achievement during this year of execution from NTP issuance date till the end of 2019 or January 2020. So what the project company has done from the financial side, so financial close has been reached by the beginning of 2019. We have also got the CBI climate bond certificate for the first renewable project finance. So it is the first project finance project in the region, in the GCC region, as renewable project obtaining this climate bond certificate. This is very important for the project and also for the region, because it attracts many investors, and this is very much needed, even if not for the project, but for the region also. As I said, it's very much important. From the execution of the project side, so we have finished the central tower, the concrete parts, the civil construction has been achieved, and that was a big milestone for Noor Energy 1. So it is currently erecting the MSR, and the lifting is planned to be started by May 2020. For the central tower and heliostat installation, it has started ahead of schedule, which is very good for the project. We have completed also the procurement of major equipment. As I said before, it was very challenging at the beginning, but then it has been done on time. So we have completed the POs of transformers, turbines, heat exchangers, molten salt tanks, etc. There are other equipment also that have been added to it. I have also been informed that we have received the overflow vessel on site, which is a huge overflow vessel because of the amount. I mean, you can see for that many hours of storage, and you would need the vessels, and the tanks are huge in term if we compare it to other projects. So the parabolic trough MAF is also completed, and the installation of the parabolic trough unit 1 is ongoing. And the last point that we have reached also is on health and safety, very important in this case. So we have reached more than 4.2 million safe man hours, and these are for a total of 3,200 employees on site. I would like just to say that 3,200 employees on site is not the peak time yet. So it's going to be doubling or more when we will be at peak time. Yeah, so I will just show you some photos of the site to give you an idea on how it is. So the central tower on the left, you can see that below we have the molten salt receiver, which is under erection down. On the right also you can see the central tower power block, which is also under construction. Then we have the parabolic trough 1, the solar feed. You can see the collectors are under installation, and then the power block also is under construction. So you see what you see here is the tanks that are needed for the project for storage. So here is a general view on the central tower unit. These photos are from January 2020, I think. So right now the execution should have progressed more. And on the right you have the parabolic trough 1 unit. So that photo on the left is when we finished the concrete tower structure ahead of schedule. And then, as I said before, so the project has been awarded, has a lot of records, so it has awarded it has got many awards. And some of, I mean, the latest one was during the PFI, and it was awarded the Power Deal of the Year for Middle East and Africa project. Yeah, and that was all from my side, I think. 1 hour.
Thank you very much, Miriam. You also started a little bit later, so you're good.
Oh, yeah?
You can take off the presentation. We have a few questions here for you, so we're just going to go through those. Okay, so here we go. Right. It's asking here, the 7.3 cents includes PV and also CSP, or is only the CSP plant? Maybe you can explain a bit more about that tariff.
Yeah, so the project has been, was a 700 megawatt PV, 700 megawatt CSP with 7.3 cents dollar per kilowatt hour. And then we have added to it the 250 megawatt PV with the tariff of the PV at, it was 2.4 cents per dollar per kilowatt hour. So it's different. We have added it later just to bring more value to the project in order to dispatch during the day instead of using the CSP during the day.
Thank you very much. Okay, can you please explain how and why the tower and parabolic trough combination? I understand the stranded dust in this area affects the efficiency of the tower. So how and why did manage?
So, okay. So as we said, so there are some requirements from our clients. And I mean, we are a developer, we are not an off-taker. So we have to satisfy the requirements of our clients. So as I said before, the project was 2 towers of each 100 megawatt and 8 hours at least of thermal storage. Sorry, of storage. So well, there were some conditions also. So we did not go with an alternative proposal, as I said, just like that. So the conditions was that we needed to have 100 megawatt central tower, at least one, and we needed to have at least 8 hours of storage. That was the condition that we needed to comply with if we wanted to go to the alternative proposal. And the way we did it is that if the client is saying that there is no project without the 100 megawatt, then we had to comply with it. So this is what we did. But when we have seen what the tower is generating and we have seen what was the tariff brought by the tower, we tried to find a solution in order to decrease this tariff as much as possible. So we have worked on the parabolic trough unit. Then there was a lot of work done in terms of simulations and pricing also to move from having just one tower with 100 megawatt and at least 8 hours of storage, to add 1 unit or 2 units or 3 units of 200 megawatt or 300 megawatt or 400 megawatt. So there was a lot of work done behind that in order to compensate the cost of the project itself, together with the generation that we are getting from it. Not only that, but we had to see also in the market what is feasible to have. We couldn't have, for example, units of 500 megawatt each parabolic trough. So we had to go to the market, see what are the equipment that are available, see what is the quantity of salt that is available, what is the quantity of HTF that is available, who are the subcontractors and the suppliers who can supply that amount of equipment with this capacity to the project. And then the conclusion at the end was to have just one tower, for instance, of 100 megawatt instead of having 2, 3, or 4, and 3 units of parabolic trough of each 200 megawatt. For instance, if we went to 300 megawatt, it wouldn't have worked.
No, absolutely. I mean, it's a large plant, right? The scales come into there.
Exactly, yeah.
Okay, a question from Jonathan Walters. Hi, Jonathan. You know, we missed you. It's really early where you are. So Jonathan says, where do you think Aqua will do a 24-hour solar next, and at what price? This is not an easy question, but it's an opportunity to shine, Miriam.
Sorry, what Aqua Power would do?
When are you going to do 24-hour solar, and at what price? Where and at what price?
This is already a 24-hour solar.
The next one. It's asking you the next one.
The next one. Look, I think we are waiting for also the government to carry on working on CSP. I think the energy demand is increasing, so is always increasing. So we want to see this happening very, very, very quickly, because we would be very happy to provide the 24 hours dispatch. But not only 24 hours, we need to have also economies of scale, which is a very important point here in CSP. If we are talking about 100 megawatt projects of CSP with 24 hours storage, I mean dispatch, then it wouldn't be that competitive. It wouldn't be as competitive as what we are doing now here in Dubai with 700 megawatt CSP. So we need off-takers, we need government also to allow developers like us to at least offer something which is feasible, sustainable, and also which makes sense either from the demand side or also from the tariff side.
So I can tell you that yesterday, if you weren't there, I'll tell you what happened. Paddy, who is the CEO of Aqua, reckons that anywhere in the Middle East or in places in the Middle East, you could do plants now at like the 6 cent mark, and in like the next sort of 3 to 5 years, you could do it even at 5 cents. He thinks 5 cents is what it's at.
Yes, because in the Middle East, there is the load consumption is very important at night. So by the end of the day and during the night, there is in summer especially, most of the locations in the Middle East, populated locations, would need 24 hours dispatch. So the 24 hours is going to be there, yes or yes.
And what about the north of Africa? Is it something similar? Because I know that you know well also the north of Africa. You've worked quite a lot.
Look, for instance, in Morocco, the load consumption is different. I'm not sure if they are going for a 24 hours or not yet, but I mean, it has to make sense, of course. If we are talking about 24 hours, then you know, the CSP is all about building the storage. Without storage, CSP is not really required. You would go just to do PV. You don't need CSP. So having a load profile, consumption profile during the night, which is important, like here in Dubai or in the Middle East generally, helps a lot.
Okay, let's do one more, and then you know, we'll move on, and we'll thank you. Okay, so it says whether storage capex was part of the 7.3 cents. You know, I know this is quite self-explanatory, but apparently it wasn't clear. So the storage capex was part of the 7.3. Is that correct?
So yeah. So when we talk about capex, it's within the $4.3 billion. Okay, so the storage, yes, it was there. So that includes the whole project cost. When we say whole project, it means all the capex, all the works on site, all the engineering, all the financing costs, everything is there. So we are talking about 4.3, and yes, within the 7.3 cent tariff, yes, the storage is there.
And one more, just one more, and I'll let you go. Are the CSP and the PV plants interconnected in any way?
So it's I don't know what they mean by interconnected, but when we dispatch, there is the dispatch of PV different from the dispatch of CSP, for instance.
You have some parasitic consumption of the plant as well?
Yes, we do, and for this we are using other PV, which is different than the PV that is dispatching. That is something else which is not allowed to be dispatched.
So it's a little bit oversized, the PV, actually, on top of those 250.
The 250 is just dispatch, yes. It's just what goes to the grid, but other than this, there is PV for internal consumption, purely internal consumption, which is not going to pass by the meter, for instance. It's not going to be, yeah.
So thank you very much, Miriam. It's been great hearing you. You know, you've been involved in so many CSP plants now. I've lost count. I mean, how many megawatts of CSP have you been involved?
Look, we always want more.
No, I know. But not only from Agua, also in Abengoa. You know, we were like, you've worked in most of them. You've worked in the ones in Morocco.
Yeah, I love CSP, so I'm looking for the next one.
You guys, you're not the only one. I think I like to see the clap.
I know.
You know, like of all the CSP lovers out there, please send the claps for Miriam. You know, silent claps. Jonathan Walters came up with this yesterday, and I love it. Thank you ever so much, Miriam. You know, oh look, see, Asma's already clapping. Thank you very much, Asma. Okay, excellent. So thank you very much. We're gonna, you know, just get in touch with us if you need any further information. I think Miriam here gave you a lot of information. Of course, this project is still being ongoing for a while.